So now I'm going to talk a little bit about piecewise functions. Piecewise functions can be used to define a function that is continuous or discontinuous. So if my piecewise function was f of x equals x plus 5 for values if x is less than or equal to 2, and negative x squared plus 8x minus 8 if x is between 2 and 5, and x plus 2 if x is greater or equal to 5. Well, a graph of this would look a little like this, where this is 5, this point is 2, and this point is 5. Now, each part of the function is called a branch. So this part would be a branch, this part would be a branch, and this part would be a branch. Each of these little parts is called a Boolean variable because it can either be true or false. If it is true, then the condition inside over here is equal to 1, and if it is false, then it is equal to 0. So for this function over here, we can examine it and find some limits. So the limit as x approaches 2 from the negative side of this function f of x, it approaches this number over here, which is 8. However, if we approach 2 from the positive side, it approaches the number 4. And since these two values are different, we know that there is no limit as x approaches 2 from the neat little property we just learned. So this does not exist. Over here, notice how we've still defined the piecewise function using a piecewise function. However, it's still continuous because the limit that x approaches from the left of 5 is equal to 7, which is the same value that x approaches when x approaches 5 from the positive side, f of x approaches 7, which means that the limit as x approaches 5 is equal to 7 from the property we just learned.